Okay, and now we will see the problems related to the factor of safety and reliability. Now that is the first problem. A cantilever beam is made up of plain carbon steel 25C8 and having the mean yield strength of 280 Newton per mm square. The standard deviation given is the 4040 Newton per mm square. First off, it is subjected to bending stress with a mean of 180 Newton per mm square and its standard deviation is 20 Newton per mm square. So what is to determine? There are three parts we are going to find out. First one, reliability of beam, minimum factor of safety, and third one, average factor of safety. Okay, and for that we are going to use the areas below the normal distribution. Okay, now in this problem, if you read carefully, just stop this video and read it again. Okay, so here you can see the two parts. The first one, the beam is made of 25C8 with the mean yield strength of 280 Newton per mm square. Mean yield strength and its standard deviation 14 Newton per mm square. This is given. And second part, it is subjected to the bending stress, that is a mean bending stress of 180 Newton per mm square, and its standard deviation is 20 Newton per mm square. So these two parts are given, that is value, standard deviation, value and standard deviation. So here the mu s value is given, its standard deviation, mu sigma value is given and its standard deviation is given. Okay, so these two distinct parts are there. Okay, and we have to find out these two parts and solve the problems related. Okay, now in this problem, what is the data is given? First, the mu s value is given. What is mu s? 280 Newton per mm square. Now its standard deviation is also given. It is 40. Sigma s, it is 40 Newton per mm square. Then what? Mu sigma value is given, that is a mean mu sigma. How much it is there? 180 Newton per mm square. And the standard deviation is the sigma sigma, it is 20 Newton per mm square. Okay, so this is the strength value, this is what the stress value, strength value and stress values we have over here. Okay, now the first part, the strength of beam, which is generally denoted by S. Okay, so mean standard deviation of strength of population R, mu s is equal to, it is 280 Newton per mm square. Okay, 280 Newton per mm square. Similarly, what? Sigma s 40 Newton per mm square. Second part, stress induced in beam. Notation is the symbol is given for us. Okay, mu sigma, it is how much? 180 Newton per mm square. Sigma sigma, it is 20 Newton per mm square. Okay, now third part, it is the margin of safety. Margin of safety. Okay, now how to find out the margin of safety? Yes, how to find out margin of safety? Already we have seen the formula. It is m is equal to s minus sigma. Okay, so keep it in mind. M is equal to s minus sigma. Okay, so mu m is equal to mu s minus mu sigma. Okay, now we have the values. 280 minus 180 is equal to 100 Newton per mm square. Okay, so this is what mu m is nothing but the mean margin of safety. What? Mean margin of safety. Okay, so we have the value of mean margin of safety. Now what is the standard deviation for this? What is the standard deviation for? We have seen the formula. What is standard deviation? Sigma m is equal to square root of sigma s square plus sigma square, sigma s square plus sigma square. Okay, and we have its standard deviation also, 40 square plus 20 square, and finally we will get it is as 44.72 Newton per mm square. Okay, so you have to solve this by yourself, okay, and check the values. Okay. Now while learning the margin of safety, if you remember, I taught this margin of safety normal curve, okay, for the margins, and also I shown this is what the m is equal to 0, and on the left hand side, on this the left hand side, if you see, when m is equal to 0 and the left hand side of that m is equal to 0, this is what the failure, this is what the failure, and on the right hand side over here, this is what the accepted, this is what the accepted. Okay, so I hope this you remember that one. Okay, now what we have to find out this m is equal to 0, that is for that the z value we have to find out. Okay, and if we know the z value over here, if you know the z value, if we able to calculate this z value over here, this z value over here, then we can also able to calculate the area. Okay, this area and this area we already know it is a 0.5. Okay, but we don't know this area, so once we get this z value, okay, we can able to get this area. Okay, and then we can say this is what the margin of safety. Okay, or we can say it is the reliability of the. Okay, now how to calculate? Yes, tell me. The reliability of beam are the failure occurs if the margin of safety, if the failure occurs at the margin of safety m is less than the 0, then at m1 is equal to 0 Newton per mm square. m1 is equal to 0 Newton per, and that 0 we know right over here. Right over here we know this is what the 0. Okay, because on the left hand side there is a failure and we know m is the 0 over here. Okay, so that's why m over here it is the 0. Okay, so z1 is equal to what? m1 minus mu m divided by sigma m. Okay, this is what these two we have already calculated. m1 is 0. Okay, so put the values, then we will get answer. Okay, so 0 minus 100 divided by 44.72, so we will get minus 2.24. value of z as the minus 2.24. Okay, now we have the areas. Okay, which area? The two areas we have right over here. Okay, so I will write down, this is the A1 area and this is what the A2 area, where A1 is ranging from mu m to m is equal to z is equal to minus 2.24, and second is the 0.5, that is A2 is the 0.5 we know, and this is what z is equal to 0 to z is equal to minus 2.24. Okay, now we have to look into normal chart or normal distribution table. Okay, to find out what the value z is equal to minus 2.24. okay, and area of that we are going to find out how much it is. Okay, Now this is what the normal distribution table, and we are going to find out 2.24. This is what the 2.24, okay, 2.2 right over here, and this is what the 0, 1, 2, 3 and 4. Okay, so this is what the 2.24, and it is 0.4875. 0.487. So for z is equal to 2.4, the area A1 is equal to 0.4875, and A2 is 0.5, that we already know. Okay, so A1 plus A2 is equal to 0.4875 plus 0.5. So finally we are getting 0.9875. That is 98.75%. It is the reliable one. Okay, so the reliability of that component is the 98.75. that is the beam. Okay, now the second part is to find out the minimum factor of safety. Minimum factor of safety. Okay, that we are going to be find out. Okay, now how to find out minimum factor of safety? NF minimum, that is NF minimum, is equal to minimum strength divided by the maximum stress. Okay, so do remember this, it is the minimum strength and maximum strength. So what is the minimum strength? Minimum strength, the average mean stress we are knowing, it is mu s, right? The mean strength we are knowing. Okay, minus 3 times the standard deviation of the strength divided by mu sigma, this is for the stress, the mean stress minus plus 3 times the standard deviation of the strength. Okay, so just we are going to enter the values. 280 minus 3 times 40, 3 multiplied by 40, this is 180 minus 3 times multiplied by 20. So finally we are getting 0.687 is the minimum factor of safety. Okay, similarly if it is asked, it is not asked in the example, but suppose if they ask you the maximum factor of safety. Okay, maximum factor of safety. Okay, so for the maximum factor of safety we will have the formula NF max mu s plus 3 times sigma s divided by mu sigma minus 3 times sigma. So this is the formula you have to use and find out the solution. Okay, and in our example they have asked to find out the average factor of safety, and F, average factor of safety, which is equal to yes, mean strength divided by mean stress, which is equal to mu s divided by mu sigma, which is equal to 280 minus 180, and we are getting it as a 1.55 or 1.556 as the answer, final answer. 1.556 as the final answer. Okay, thank you.